Okay, let's talk about physical states and phase changes. So first, physical states. This is something that you should already be familiar with. We've talked about a little bit, but also this is just most of it common knowledge just after, you know, dealing with things. Um, And so most people would know some characteristics of solids, liquids, and gases. Specifically, things like that solids have kind of a fixed shape, whereas liquids will take the shape of their container. And gases also will take the shape of their container, whereas gases will expand to fill the container, and liquids will just take up however much space they need. Um, and a solid is just this rigid material, whereas a liquid you can actually pour, it can flow. Um, and then a gas, if you actually open the container, of course, it's going to come out and expand even further into, you know, the opening, whatever it's opened into. Um, And then in solids, you have kind of your particles fixed in space. Now, as long as it's not at 0 Kelvin, there's always some vibrations in these particles, but they're pretty much fixed in place. They can just kind of move a little bit, they can vibrate, depending on what the actual temperature is of that solid. Whereas in a liquid, you have this constant motion, but the particles are in contact with one another. And so they're just constantly moving around one another. Whereas in a gas, you really have complete separation of your particles. There's actually space in between them. So those particles are constantly moving. They could bump into one another, but most of the time they're just on their own. Um, and you can think about if you were to try to compress these things, a solid, really, you can't compress it. Occasionally, you might have a solid that has a very loose structure, has a lot of gaps in it, that you might be able to kind of crush it and seemingly compress it. But in general, no, you can't. A liquid, you can get a slight amount of compression, but it's very little. The particles are pretty tight together already, just like in a solid. Whereas a gas, there's so much space in between them, you can make significant changes in volume by compressing them. Um, Now, let's see. Another thing that I don't think is in this table anywhere, sometimes people will talk about fluid phases. Liquid, of course, is a fluid phase, but a gas would also be considered a fluid phase because it moves freely. And so that can be useful to realize what people are talking about when they're talking about the fluid phases. A solid wouldn't be a fluid phase. Um, so you should be familiar with some basic characteristics of solids, liquids, and gases, what's different in them. And so in the solid, things mainly are fixed in place, whereas in a liquid phase, they've got a lot more motion, and in the gas phase, they've definitely got a lot more because they have way more freedom. And so motion's a big part of it, which is all tied to kinetic energy, which is tied to the temperature of something. And so if you increase the temperature of something, you're essentially putting more kinetic energy into the system, so things move more. That's why when we increase the temperature, things can melt or can evaporate. And so it'll transition to a phase that has more freedom to move when it has more kinetic energy. And so let's talk about the different phase changes you can have. You can actually have endothermic phase changes and exothermic phase changes. So it's all talking about heat going in or out of the system, okay? And the system is our sample, okay? So you have some sample and it could absorb heat. And when it absorbs heat, it can undergo phase transitions. Now it can also change temperature, So there's really two things that happen with added heat. There's temperature changes and phase changes. The phase changes occur when you reach the phase transition temperatures. So like your melting point and your boiling point, and even your sublimation point. And there's more terms for those, but your transition temperatures. Once you get to that, as you add heat or remove heat, then a transition occurs. So your endothermic phase transitions, most people are familiar with these. Usually we would talk about solid to liquid as being a melting process. So melting is your phase change, but occasionally when you get into more technical applications, people will call that fusion, which seems a little odd, but it can also be called fusion when you transition a solid to a liquid, and that is an endothermic process. Heat has to go into that system. Another one is evaporation. That's when we have a liquid convert to a gas. You can also call that vaporization. And then we have a solid can transition directly to a gas. That's a little more unusual. Most of the samples we would deal with would go from a solid first to a liquid and then to a gas. But if you had, say, dry ice or solid CO2, then at standard conditions, under standard pressure, it's going to naturally transition directly to a gas. And that process is called sublimation. So all three of those processes require energy. And so that energy comes in as heat. And so you heat up that sample and you can cause these processes to occur. And so you're adding this heat. And so that's actually giving the system more kinetic energy. And so the things start moving more. So the solid particles can break free of one another. The liquid particles can break free of one another and get even more freedom. Okay, but then we have the reverse of these things, which are going to be exothermic. They're going to be processes that release heat. So the opposite of melting is freezing. So instead of going from a solid to a liquid, we're going from a liquid to a solid. And so, of course, in order to freeze something, you need to take heat out of that system. Okay, so you're taking energy out of it. So that is an exothermic process. Your sample is releasing heat. We can have condensation. That would be the opposite of evaporation or vaporization. So condensation, you have a gas and it condenses into a liquid. And so that process, of course, those gas particles have lots and lots of energy that are allowing them to move around freely. And so in order to condense them down into the liquid state, they need to release some of that energy so that then they can come together and actually stay put. And then we have the opposite of sublimation, we have deposition. So going from a gas to a solid. And so you're depositing onto a surface essentially. And so that again is an exothermic process because those gas particles have lots of energy and they need to release it in order to solidify. And so you've got to know the basics of your different physical states, and you should be familiar with the terminology associated with the transitions between those physical states, what the terms are, and whether or not they're endothermic or exothermic processes.